Alright, I have been trying to go through these pretty quick, but remember, you can stop and go back through these if you don't understand them, and I want to thank you for making it this far, even those of you that put me on 1.25 speed. It's kind of proof intensive, and it's a lot of thinking. So without any further ado, let's get the last one done. Remember, we've proved opposite sides congruent, we've proved opposite angles congruent, and now we're going to do the last proof. That is to show that a diagonal bisects each other. And I just glanced at this and played around with some numbers. I wanted to see where they were going, and I get it. So I'm going to show you what they're going to do. Is they're going to prove this little triangle is congruent to this little triangle, and then prove the parts are congruent through CPCTC. So let's dive in and get that. The first thing it is ABCD is a parallelogram. That's given up here. All right. And now what we want to prove is these diagonals bisect each other. So let's start by proving triangles. So we know that. And I actually don't need all of these, so I'm going to just say AD, this one right here, is parallel to BC. And that's the definition of a parallelogram. Now, when you see a flow proof, everything over here is going to go off of that parallel side, and then meet back up with the fact that this, right, we're also going to say AD, marking it here, is congruent to BC. And since we've already proved it, we can say opposite sides of a parallelogram are congruent. Now, I can prove these other two sides congruent, but I'm not going to need it here. Alright? So, once we get this, we have two angles we can prove congruent. I'm going to mark it here. I'm going to prove that this angle is congruent to this angle, right? Because we have alternate interior angles here on those parallel sides. So I'm going to say angle, right? DAC, that's this one, is congruent to angle, and that looks like BCA. Alright? Now I'm going to do the other side. I'm going to come over to this side and do this angle here and this angle here with the same reason, alternate interior. So I'm going to say angle ADB is congruent to angle CBD. Alright? Again, alternate interior angles. So if you notice, on both of these little triangles, and I'm going to go ahead and draw those little triangles out right here. That one and that one right there. I have angle, side, angle. So those triangles are congruent by ASA, angle, side, angles. Let's say it. Triangle AED is congruent to triangle. Let's see, what matches A? It looks like CEB by angle ASA, angle triangle congruence theorem, angle side angle. Alright? And once you do that, as long as the parts match up, you can say CPCTC. And if you look at it, AE matches up with CE. So I can just write that down. Segment AE is congruent to segment CE, comma, and segment BE is congruent to DE. Well, now we've proved all four things, right? We proved opposite sides are congruent, opposite angles are congruent, and the diagonals bisect each other. There's a little bit more to do, and we'll finish it up in one more video, but since this is on the same page, let's go ahead and look at this. Alright? Here's the properties of a parallelogram that we've known. Alright? We're just matching things up. So we see side AD right here. That's going to match up with BC. So I'm going to say BC right here. We see side AB right here. Let's mark it. That's going to mark up with the opposite side CD. So there's our opposite angles opposite sides are congruent. Angle A, opposite angle is angle C. There's our opposite angles right there. We see segment BC. Well, we've already done that. We know that matches up with AD. Alright, segment CD right here. We've already done that the other way, so that's AB. They match up with each other. Angle C over here matches up with angle A. The only thing they didn't do is they didn't make angle AB match up with angle D, but we know that's true. Now we're going to draw diagonals. Let's draw diagonals, alright? Here's a diagonal right here. Boom, here's a diagonal right here. My guess, because I saw an E down there, they want us to make this E. So we got AE. Well, since it's bisected, that's the same as EC. Right? These two match up. 2, 3. 1, 2, 3. CE matches up with AE. That's just the same thing backwards. BE to here. 1, 2, 3, 4. 1, 2, 3, 4. Matches up to ED over here. And DE matches up to BE. Just the same thing. These are the same thing backwards. All right. So we have done that page. I think we just have one more page. That is my guess. It looks like that is it, and there's no back. So we are going to get through this, and I'll talk to you soon.